This week's Futurist looks at how the future of shipping is shaping up. The Alexis shipyard in Greece has been producing ships for around 2,500 years. Workers here have used their predecessors' know-how to develop vessels that today make up one of the most reliable and efficient means of transport. Design challenges have been met and engineering obstacles overcome. One of today's biggest hurdles is pollution. The coordinator of the Hercules project explains how that concern is being tackled.
Well, this is a new build ship, so obviously it has the state-of-the-art engines built today. The objective is that since there is room for improvement, both in efficiency and in emissions, we try to improve these engines so that we can get the same power or more power out of them using the same fuel but with less emissions. And so this is the objective of the Project Hercules.
Shipping is one of the greener methods of transport, but there's always room for improvement. Virtually all ships use diesel engines that run on cheap fuel that emits carbon dioxide, nitrogen oxides and sulfur. A cleaner fuel would require refining facilities that simply do not exist, so the most realistic way of cutting emissions is to burn less fuel. Hence the quest for a more efficient engine. That's what the many different partners that make up the Hercules project are aiming for. Armed with a €33 million budget, half of which comes from a European Commission subsidy, Hercules has been on the case for 3 years. It's even brought together fierce competitors in the maritime market. Environmental concerns are obviously pressing, but the fact it will save shipping companies money makes it all the more enticing. With the rising price of oil, an engine that makes fuel go that little bit further is a welcome advantage of going green.
The higher the oil prices go, the more interesting would be to have technologies which improve the efficiency. And this is a general rule. If the oil prices are down, nobody cares about efficiency improvement. But it's not only the price of what you're burning, is what comes out as a result of the burning of fuel.
To make engines more efficient, all the components need to be changed. It's a complicated task, and one that needs the expertise of many contributors.
Things like an exhaust gas boiler. The project encompasses most of the countries in Europe. We have about 10 countries participating, and more than 40 organizations, that is including industry, research organizations, universities, sub-suppliers of engine makers. The core of the project are the two major engine maker groups, and I would say that this is important because these two groups are in fact competitors in the world market. Together they hold more than 85 or 90% of the world's market. So in fact they are the world leaders, and they have decided to collaborate.
The project is spearheaded by the two market leaders, MAN Diesel and Wärtsilä. Before Hercules, any cooperation between the two was unthinkable, according to bosses at Wärtsilä's factory in Vaasa, Finland. Now, though, their research and development departments have put their heads together to fight a common foe, the growing Asian.
It was a downturn in the industry a few years ago, and we both were very concerned also, together with MAN and us, about how the industry might turn from Europe to Asia. At the same time, we noticed that by teaming up, we also can get contribution from EU, and we started a very well focused cooperation.
The next phase of the Hercules project hopes to reduce fuel consumption by 3% and nitrogen oxide emissions by 30% by 2011. Another EU-backed initiative is the improvement of safety in ice-covered Arctic waters. The Safe Ice project comes at a time when Arctic traffic is on the rise. Scientists at Helsinki's Technological University are using miniature-scale models to see how successful a ship's hull is in breaking the ice.
We have more reliable design methods, how to design the ship hull to take account different ice conditions, to take account the statistics of ice loading, and we analyze the damages we have found. We have analyzed the damages so we know what kind of loading will happen in ice.
Global warming means that new Arctic paths are expected to open up as the ice retreats. Traffic is also set to increase as more oil and gas is shipped from newly found sources in northern Russia.
We are quite sure that in near future the activities in Russian Arctic, for example, in Russian Arctic will increase, and this kind of expertise is needed to design ships for these conditions, to find the oil and gas and to transport the oil and gas from Arctic to, for example, to Europe.
At the moment, all ships entering Finnish and Swedish ports are helped out by icebreakers, special ships that forge a path through the ice for tankers to follow. But a lack of these trailblazing ships and increasing demand means this cannot happen, and many ships are running the risk of accidents. Other frequent users of the Arctic, such as Russia and Canada, have no universal regulations. Safe Ice aims to create a common approach to ensure ships are specially designed to meet the challenge put to them by icy conditions. It will also improve the charting and forecasting of the waters, as well as traffic control. Shipping is already less expensive and more environmentally friendly than land or air transport. But that does not mean it's all plain sailing. There is no room for complacency. Advanced research projects such as Hercules and Safe Ice are helping to raise the bar in the industry in anticipation of the difficulties that lie on the horizon.